In the previous class, we explored the derivative of the transcendental function, natural logarithmic function, which is algebraic and is given by 1 over x. Now, let's observe that the derivatives of inverse trigonometric functions are also algebraic. Let's start by examining the derivatives of the three fundamental inverse trigonometric functions. First, the arc sign function. Firstly, defining the domain as x. Be sure to check the range of the arc sign function. Using the inverse function, swap x and y. Apply implicit differentiation. The derivative of the sine function is the cosine. And dy dx becomes 1 over cosine y. Here, we will use the Pythagorean identity. Cosine y equals square root of 1 minus sine squared y. This is positive, as confirmed within the given function's range. Dy dx becomes 1 over square root of 1 minus sine squared y. Substituting sine y equals x into the denominator. Dy dx becomes 1 over square root of 1 minus x squared. Using a general form u instead of x, we derive the familiar formula for the derivative of the arc sign function. Next, the arc cosine function follows a similar process to the inverse sine function. Define the domain as x. And be sure to check the range of the arc cosine function. Swap x and y using inverse function. And apply implicit differentiation. The derivative of the cosine function is negative sine. And dy dx becomes negative 1 over sine y. Using the Pythagorean identity. Sine y equals square root of 1 minus cosine squared y. This is positive, as confirmed within the given function's range. Dy dx becomes negative 1 over square root of 1 minus cosine squared y. Substituting cosine y equals x into the denominator. Dy dx becomes negative 1 over square root of 1 minus x squared. Using a general form u instead of x, we derive the familiar formula for the derivative of the arc cosine function. Thirdly, let's delve into the derivative of the tangent inverse function. Firstly, define the domain as x. Swap x and y using the inverse function. Apply implicit differentiation. The derivative of the tangent function is secant squared y. And dy dx becomes 1 over secant squared y. Here, we'll use the Pythagorean identity. Secant squared y is equal to 1 plus tangent squared y. Substituting this, dy dx becomes 1 over 1 plus tangent squared y. As tangent y equals x, substituting x into the denominator. Dy dx becomes 1 over 1 plus x squared. Using a general form u instead of x yields the familiar formula for the derivative of the arc tangent function. Let's look at an example problem. The given function is the arc tangent function. Firstly, differentiate to get the derivative with x over 2 in the numerator and 1 plus x over 2 squared in the denominator. Simplify the fraction. since the x value of the given point is 2. The slope of the tangent is 1/4. Utilizing the point-slope form makes it easier to derive the equation of the tangent. Therefore, we have successfully formulated the expression for the tangent line we seek. See you next time.